Alright, let's open up to the chart that we were filling out and completing yesterday, page 249. Alright, so yesterday, what's up? Yeah. We didn't get to it during first period, so I'll probably just stop at 4.2. Okay, give you some homework time. Alright, so yesterday we were looking at different characteristics of an equation and how that characteristic from the equation might be related to the graph. Remember, our overall goal by the end of this chapter is for me to give you an equation and you be able to graph it, or vice versa. Me give you a graph and you be able to write the equation. So we got to figure out where some of these characteristics are on these rational functions. Can we identify x-intercepts, holes, vertical asymptotes, y-intercepts, horizontal asymptotes? We're going to talk about all these different things that we can use to our advantage. So we were filling out this chart yesterday, kind of exploring restricted values, x-intercepts, and y-intercepts. Okay, we're just going to keep adding to the list as the unit goes on, but for right now we're just focusing on these three special kind of characteristics. I forget yesterday though, how far did we get into this chart? We're on the last one? Okay, let's try the last one as a review or a refresher. So in our first column we want to completely factor it, and then based off the factors find the restricted values. So looking at the bottom, we got to think of two numbers that multiply to 3 but add to 4. 3 and 1, okay. And then for the bottom, two numbers that multiply to -3 but add to 2. All right, +3 minus 1. So now that everything's completely factored, can we find those restricted values, the numbers that would not work if we were to plug them in, meaning we'd get an undefined result? What numbers are we not able to plug into this fraction? Okay, Caitlin?
-1 and 1.
Where's the -1 coming from? The top. And then the positive one coming from the bottom. Okay. Did you pick those because we know this x plus 3 is going to cancel? Okay. I understand that. If you plug in -1, that's going to make the top 0 but not the bottom. So that would be like 0 over a number. Can we take 0 divided by a number? There's a difference between those two. This would be 0. This would be undefined. Okay, so we essentially got to figure out what makes the bottom 0. So I like your number 1 because that came from down here. Is there another number that would make the bottom 0? Yeah? -3. Okay, we have two factors on the bottom, so we're going to have two answers, two restricted values. Alright, so if these are the two numbers we cannot plug into the fraction, then we should be able to use those to help us write the domain. Okay, we know we can plug in any number we want into a fraction as long as the bottom is not 0. So we're going to go from -infinity to +infinity, but we're going to skip over -3 and 1. So we'll go from -infinity to -3, -3 to 1, and then 1 to infinity. Alright, let's look at the next one. Set each non-canceling factor of the numerator, meaning the top, equal to 0. So Caitlin kind of already mentioned to us that she noticed that x plus 3's are going to cancel. They're going to go away. And we want to focus on what's left in the top after we do the canceling. So that's going to be this x plus 1. And if we solve that, we'll get -1. All right, so can we think about, maybe from yesterday, look at the chart to kind of get a pattern. Can we figure out where the x-intercept is on the graph without using the graph just yet? What do you think, Lainey? -1. Did we notice from yesterday how this result in the third column matched the result in the fourth column? Do we see that all the way through? Okay, so educated guess, if we got -1 here, then the x-intercept would probably be -1. We'll check that out in a second. Okay, moving on, what about the constant term of the top divided by the constant term of the bottom? Looking at our equation, we have 3 over -3, so simplifies to -1. Can we think about where the y-intercept is on this rational graph? Did you notice a pattern from yesterday maybe within the chart? Okay, Caitlin? Probably -1. Okay, we saw how the result of the constant terms kind of matched the y-intercept through the table. So if we check it out graphically, okay, if you flip the page or look on the previous one, P of x is the bottom right-hand corner, and based off of our analysis of the equation, we should have an x-intercept at -1 and a y-intercept at -1. Looking at it, seems like that checks out. Okay, x-intercept -1, y-intercept -1. So after looking at just 4 examples, okay, trying to find a pattern between all these different analyses that we've been doing, I want to make sure that we can formally write down the connections between the graph and the equation. So we're going to do that on the next page. We're basically going to summarize the patterns that we saw within this table. So if someone asked you, hey, how do you find the restricted values or the numbers that don't work in a rational fraction, what would you tell them? What do you think, Grace?
The numbers that make the bottom 0.
Okay, numbers that make the bottom or the denominator equal 0. How can we figure out those values? Yeah? Factoring can get us there pretty quickly. I mean, if you don't want to factor, you might have to guess and check a few times until you find them, but factoring is going to be very quick. Okay, so we'll say factor to find the numbers that make the bottom 0. All right, so you just helped out your friend. Someone else comes up to you, says, dude, how do you determine the domain? Help a brother out. You give a shot, Lainey? There you go. I'm going to say it word for word. Negative infinity to positive infinity, skipping over restricted values. I like it. Friend number 2, happy. All right, friend number 3. How do you determine the zeros of a graph? Yeah? Okay, so we'll say cancel factors that match. And then we got to figure out the non-canceling ones, meaning the ones that are left over. Okay, so cancel factors that match and find what makes the remaining numerator, meaning the top, equal 0. Friend number 3, good to go. Friend number 4, I really need your help. I've been working on this homework all evening. I can't figure out where the y-intercept is on this graph. Can you give me a clue? It's on the graph. I don't have a graph though, I just have an equation. It's in the equation. How can we find the y-intercept? Yeah? Alright, constant from the top over constant from the bottom. Thank you so much. I really appreciate it. I think I can go on from here. Okay, so all 4 friends are happy. So what I want you to do is, now that we have these relationships down, okay, these connections between graph and function, I want to see if you can fill out the bottom 2 examples. Okay, without a graph, because we don't have those available. Okay, try to figure out the factored form, the domain, x-intercepts, y-intercept. Give them a shot.
Multiply A by C. I assume. You're wrong. You're wrong. Oh wait, 4-0 and then down 4-7. Intercepted negative double times. 3, 4, 5, 6. Negative 3/2. And this one's honestly, that's the thing. It's gonna sit me probably 10 minutes on 2. The thing that's square root. Alright, C is the constant term. D is the constant term. What is the value? What?
It's hard to tell. This little line should be an equal sign. Like equals 3, equals 12, equals 6. I know, that's why I made it here. All of them have equals 3.
Oh, so it's like a predicament. No?
Not like that. The equals and 3.
Anything.
But I like the one better. Also the fact that it's
So it's not this minus 36 equals 6. The equals is So this limit equals 36. This limit
Drake is
equals 6. This limit.
No, he's not.
So you don't have that right there.
that does not have money. Yeah. Look at him. He's so passionate. You see his stupid face that he has? When was he making that face? I'm curious now.
Huh?
When did he make that face?
Looks like it was a basketball game. Design the tree.
We're in Xbox. You're about to mistake for that. Yeah, I want to see him. It's easy to know.
It's gone.
I heard you most of the show at one time. Really?
I walked in while it was playing to check if anybody was in it. Nobody was in it, so I like sat down and watched it for like 5 minutes.
Wait, there's no one in there?
No, no one in this bunch of furries. You still play it? No, like in the movie, you just a bunch of furries. It's CGI so gross. I know. It's literally human body as fur.
All right, let's check these out. Seems like we're done. Robbie, can you factor the first one for us?
X minus 3, and then 3x plus 2 over x minus 3 and x plus 1.
Agree?
Agreed.
Agree? Sounds good. Okay. Elsie, can you find our restricted values in domain? -1. Okay, and then how did you write your domain? Yep. Love it. 2 for 2? Okay. Mason, can you find the x-intercepts?
X-intercepts, 2 over 3. Right.
I got -2 over 3. Okay. Can you describe how you got 2 over 3 or -2 over 3 as your value?
You take the top 3x plus 2, which is the factor.
Okay.
Factors, and then you put that equals to 0.
Okay.
To solve.
So why did you choose just this one and not the x minus 3?
Because the x minus 3 is cancel out.
Cancel out. They go away. So you don't have to worry about them. Okay. 3 for 3? Yeah.
I was going to say that one.
Oh, if I pull your name. Okay. Grace, can you find the y-intercept?
2.
How'd you get 2?
I divided -6 and -3.
There we go. Constant term of top over constant term on bottom. How do we do for our first function? Good? All right. Matt, can you factor the next one?
X plus 5 times x plus 2 divided by x plus 2 times x minus 2.
Okay, what was the top? X plus 5, x plus 2?
Yeah.
I like the numbers.
Wait, no, minus 2.
-2. Okay, there we go. Okay. How do we do with our factoring? All right. Travis, can you do restricted values in domain?
Restricted values. Yes. X equals 2 and then -2.
All right, and then your domain?
And domain.
Yep.
Oh, I totally forgot to do that. I can figure this out.
You can figure it out. Take your time.
We got negative infinity
Yep.
to -2 and then 2 to infinity. Or -2 to 2 and 2 to infinity.
There you go. All right, looking good so far. Hadley, can you find the x-intercept?
It's just at -5.
How'd you get it?
Well, at the top it's x plus 5, and then this x minus 2 cancels out the bottom.
There we go. X minus 2 is canceled, so we don't have to check that one. All right, last one. River, can you find our y-intercept?
5 pounds.
How'd you get it?
Divided by 6.
All right, so -10, constant at the top, divided by -4, constant on the bottom, simplifies 5 over 2. How do we do? Perfect. Okay. I know we have some time left, but I'm going to save 4.3 for tomorrow, so you can use the remainder to work on some homework. Get some work done.
How come you never raise your hand whenever she does it?